Now we're going to run through the same proof using vectors. Vectors are one of those parts of mathematics that are not going to be much use to most people in their ordinary lives, but when it comes to physics, they're extremely valuable. So here we've got the same diagram, and we're going to take AE as the vector E and AC as the vector C. We want to find two different ways of getting from A to O. And firstly, the journey from A to B is clearly half of the journey from A to X. You can see the rhombus here. So that's E, that's C again, that's vector E again. So we can simply write down that AB is equal to 1/2 of E plus C. But we're really interested in AO, so we're going to say that AO is some fraction K of 1/2 of E plus C. Now we actually know that that's going to be a nice simple number, but we'll leave it at that for the moment. Now we need to find another way of getting from A to O, and this time we're going to go from A to D and D to O. So we can say AO is also equal to AD plus some fraction of OE, or for the moment we just put plus OD. Strictly it's DO, I should put there, not because it's going in that direction. So I should make it negative, but I'll write it out again just correctly. AD plus DO. Now DO is a fraction of DE, but what is DE? We need to find it. And DE is going to be this journey from D to A, which is minus 1/2 C, plus AE, which is E. So we've got minus 1/2 C plus E for DE. So now we've got another way of writing AO. We can write AO is equal to AD, which is our 1/2 C, plus some fraction of DE, and this time we'll call the fraction M. So that's all good. Now we'll give ourselves a little bit more space. In order to compare coefficients, we're going to want to write out AO is equal to K over 2C plus K over 2E using the normal rules of algebra. But for this one, we're going to be saying that AO is equal to, and it's going to be 1/2. These two taken together, it's going to be 1/2 of 1 minus M C, and then plus ME. Now once we've done this, we can equate the coefficients, and we know that this must be the same as that, and that must be the same as this. So instantly, we know that M is equal to K over 2, and we can substitute K over 2 in here when we equate these two. So we can write K over 2 is equal to 1/2 of 1 minus K over 2. Now that can be simplified by writing K is equal to, if we multiply through by 2, 1 minus k over 2. And now we're getting exactly what we want, because that means 3 over 2k is equal to 1. 3 over 2k is equal to 1, and k is equal to 2/3. K is 2/3 of AB, and clearly we can just write down the other fraction, m is equal to 1/3. And we've shown again that the ratio AO to OB is equal to 2 to 1 as required. The next step, we'll be thinking about the altitudes of a tetrahedron, which divide the altitude in the ratio of 3 to 1. So the altitude is, the center of the tetrahedron is 1/4 of a way up an altitude.